Hi, ladies. Wrapping up Chapter 3 today on day 4 of Chapter 3, as well as the 4th B day that we've had since we've been at home learning. And I have quite a bit of stuff that I want to go over today. So a few things I'm going to go quickly through, recognizing that if you need to, you can go back and rewatch any part of this that you need to. So today, prayer update, going over review questions, prime time, there is none today. Going over classwork, homework answers, class material, which is going to be lab work, and wrapping up. So if you join me in prayer, in the name of the Father, the Son, and the Holy Spirit, amen. Lord, I am weary and don't know when this race will end in my life. I feel like I've been running forever trying to outrun this trial. Help me to stop trying to outrun my pain, but rather run with endurance the race you have set before me. I know that because of you, I am ultimately a victor over the trials in my life. I know that nothing in this world can separate me from your steadfast love. Please give me a measure of your love today. Give me the strength to endure this trial. Thank you for your love for me that never ends, and thank you for the crown of joy that awaits me forever in your kingdom. Amen. In the name of the Father, the Son, and the Holy Spirit. Amen. So I hope that you appreciate that prayer. I've been looking for some that I thought might be helpful to us. If you have a prayer that you really like or want me to share, please send them my way. So an update on homework submission, it's going much better. So thank you so much for your help. I'll continue to update my status and grading via email, and we'll just keep on going with this the way we're doing it. Review question answers from Block 6 last time. There were none. Block 7 last time. Here are the answers. Please pause it if you were in Block 7 so you can take a look. Block 8. Here are the answers. Please pause it so you can take a look. Review questions. If you are responsible for review questions for next class, please email them to me by Monday at noon. I am trying to send out a reminder as I remember, but no guarantees on that. So, ladies, if you are coming up on having to do that, it is Caitlin in Block 6, Ellie in Block 7, and Maya in Block 8. So please send those to me by Monday at noon so I'll be able to put them in the information for next Tuesday's class. Homework 3.5 answers. Here is the answers to the 3 questions you had with these. So take a look. Go ahead and feel free to pause the video. Other questions. So I had asked on your survey, why would a chemist find fault with the phrase pure orange juice? And there were a lot of really, really good answers, and it's basically because it is not a pure element. It is a mixture of stuff. There's a lot of things in orange juice, including water, pulp, potentially seeds, vitamins, minerals, nutrients, things that give it taste. There's a lot of different stuff. So it is really not pure. So a couple of things that people were asking as they were struggling with how to determine whether you have a pure substance, a homogeneous, a heterogeneous mixture. So the first thing you need to ask is, as you're looking at something, is it a pure substance or not? So pure substances mean that it's one item only. It's not a combination of things. It's not a blend of things. So the only things that can be pure are individual elements, items made from only one element, or a compound. It has a combination of elements, but you should be able to tell this by the name or the chemical formula. So on the one sheet, you had a lot of chemical formulas. It was very, very obvious. A few of your other items that you've had in your tables and charts, while they are some common themes, you are not necessarily very familiar with them. So at this point, you're doing the best that you can with the knowledge that you have, and this will get easier as you get more exposed to chemistry. So once you've decided whether it is a pure substance or not, you can determine anything that's not a pure substance is definitely a mixture. So if it's homogeneous, it has the same uniform appearance and composition throughout the entire thing. So every sample you were to take of it would look just like any other part of it. And homogeneous mixtures are commonly referred to as solutions. A heterogeneous mixture consists of visibly different substances or phases. So if it's heterogeneous, it's going to look different throughout the whole entire part. I'll touch base on this a little bit more as I go through some of the answers on the worksheet that people sent questions on. So I got a question about the light circles and dark circles that are next to each other. They do make a compound because each different shape or shading represents a different element. So other questions that were submitted, so reverse osmosis, separating by density, and chemical separation are all different processes. It's 3 different things. So the reverse osmosis was how they filtered out the salt from salt water. And separating by density was what they showed in the video by the blood, where the heavy stuff settles to the bottom and the lighter stuff rises to the top. And that's very much like the bottle demo that I showed you, where the yellow liquid ended up rising to the top and the blue liquid settled to the bottom. So that's separation by density. Chemical separation is using other things in order to chemically separate, and we will be doing some work with chromatography, and I'll show you some demos, and you'll be doing a lab at home, so you'll get a better handle on that. So filtration is just like what you've done in a sandbox. When you're sifting sand and leaving rocks behind, or maybe use a colander to drain water from pasta. So filtration is just simply separating by size using holes in something where the large item can't pass through and the smaller item can. I definitely had the typo there, so I need to fix that. So the larger item is held back by the holes and the smaller item can pass through. So in the example of the sand and the rocks can't go through the holes and the sand can. With the colander, the pasta is held back because it can't fit through the holes and the water can go through the holes. So that's filtration. Distillation is a little bit different. So I found this very short video for you to watch that I think will help explain some of it much better.
A solution of alcohol and water and want to get pure alcohol from it, how can we separate them? Alcohol is separated from water through the process of distillation. Distillation is a separation technique that is used to separate two soluble liquids with significant difference in their boiling points. Let us see an experiment to understand this process. We need a flask containing a mixture of ethyl alcohol and water. The flask is fitted with a gas delivery tube and thermometer. We also have a spirit lamp, tripod stand, wire hose, matchbox, beaker filled with cold water, and test tubes. Light the burner and heat the mixture in the flask.
So a spirit lamp in our case would be like using a Bunsen burner. They just have something different set up here.
Place the test tube in the beaker filled with cold water and put the delivery tube in the test tube. Heat the flask till the mixture starts boiling. Since alcohol and water have a significant difference in the boiling point, they will boil at different temperatures. And alcohol, which will boil at a lower temperature, will first turn to vapor completely, while water will remain in the liquid state at that temperature, and hence they will get separated. Note the temperature at which the solution starts boiling. It reads 87 degrees Celsius. Alcohol vapors formed here passes through the delivery tube into the test tube, which is kept in the cold water. The vapors condense and turn to liquid alcohol in the test tube. Keep on heating the flask. After all the alcohol gets vaporized, the temperature starts to rise again towards the boiling point of water. The vaporized alcohol is collected in the test tube to the purified form, and all other impurities remain in the flask. Distillation is used in chemical industry to separate acetone from acetic acid.
So, ladies, there's a lot of information here, but basically distillation allows you to separate things by boiling point. So in that example, the alcohol started boiling at a lower temperature. So as you heat it up from room temperature, the first thing that will boil is the alcohol. It will turn from liquid to vapor. If you can collect all that vapor and then cool it so that it condenses back into liquid, you can separate the alcohol from the water. So I hope that answers some of the questions that a few of you sent me. So a couple of things on the pages. So I think this is the page where somebody was asking about the different circles, the dark circles and the not filled in circles. So here, a filled in circle versus a not filled in circle, empty circle. These two things are different. They are representing different elements. So this ends up being a mixture of things. In this case, we've got two elements bonded to another element, but it's all connected together. So that is a compound, and there's a whole bunch of them, but they're all the same. Page 17. So I got a number of questions here. So number 12, the pine tree. It's not a pure substance. It's definitely not an element. It's definitely not an individual compound. It's not one thing as far as chemically. And every part of the tree looks different than every other part. The bark looks different from the roots, which looks different from the pine cones, which looks different from the pine needles. So this would be considered a heterogeneous mixture. Number 25, smooth peanut butter. So smooth peanut butter is not a pure substance, definitely not an element or a single compound. It's a combination of a whole bunch of things that are in there. So it is homogeneous because every spoonful will look like another if it's well mixed and well prepared. Chunky peanut butter is not homogeneous because you may get little pieces of nuts that are different sizes in different spoonfuls. Sometimes you'll get a spoonful that has no nuts. So in this case, smooth peanut butter is a homogeneous mixture. Number 28, a hard-boiled egg. It's not pure, definitely not a single element or a compound, and not every piece of that hard-boiled egg will look like another piece. You could actually get a piece that's white, you could get a piece that's yolk, and so it is a heterogeneous mixture. 37, cake with frosting. It's not a pure element or a compound. Not every piece is actually going to look like every other piece, and not every bite is going to look like every bite. Sometimes you're going to have frosting, sometimes you're not, so that will be a heterogeneous mixture. Propane gas is a compound. Propane has a chemical formula. It is only one thing. It is pure, and it's not an individual element. So hopefully that cleared up all the questions. Those were all the ones that I received via the survey. Page 18, we've got coffee. So interesting question about this. So coffee would depend on whether you're thinking of the ground up coffee beans or the drink, which I really never thought about until the question was raised. So, and it will also depend on whether you've added milk or sugar to it. So if you're thinking about just the pure coffee drink without any milk or sugar, it's not pure, it's not an element, it's not a compound, and hopefully, if your coffee is well made, each spoonful will be just like any other spoonful, so it would end up being a homogeneous mixture. So ladies, if there are any other questions on any of these pages, please send them in your form to me or send me an email if there's something individually that you don't understand that you'd like me to go over, and I'm happy to do that. So the main topics in Chapter 3 we've covered. So solids, liquids, and gases, physical properties, chemical properties, the difference between intensive, extensive, physical changes, chemical changes, elements versus compounds, which are the two types of pure substances, mixtures, which are heterogeneous and homogeneous, and we also refer to the homogeneous as solutions, and we've talked about separation techniques. So today I am going to start you on the thickness of aluminum foil lab. And so it is time for me to switch over and we'll start that lab. Hi ladies. So here is my setup for the thickness of aluminum foil lab. I have the materials here and I'll walk you through the lab. I'm going to take a few pictures, post them into the PowerPoint. So for you to do any of the calculations and answer the questions, you'll be able to do that using the pictures in the PowerPoint. So the first thing is that the purpose of the experiment is determine the thickness of a piece of aluminum foil, which is not possible to measure with a ruler because it is way too thin, by using the information that we can obtain from using the density of aluminum. So I have a graduated cylinder and some water, some aluminum pellets, and I have a ruler off to the side and a balance that I've measured the mass of these pieces of aluminum. So the first part is to I'm not going to follow it actually exactly. So instead of putting the beaker on the balance, I've actually used a weigh boat, and I will record the number and put it in the PowerPoint for this. So the mass in grams of the aluminum. I'm going to put some water in the graduated cylinder. And this may not be right on a line, so I'm going to take a picture of it so you can take a look at it and determine what the exact volume is from the picture. That turned out okay. Then I'm going to go ahead and I'm going to put this known mass of aluminum pellets into the graduated cylinder. And the volume is going to increase. Because remember, this is the volume displacement like we talked about in class. So the volume has increased, and the volume that it increased by is due to the volume of the pellets. Trying to get a better picture here. So from those two pictures, you'll be able to determine the volume of the aluminum pellets. From there, and knowing the mass, you can determine the density of the aluminum. So the second part of this that I'm going to video is, actually I'm not going to video it very much. I have a piece of aluminum foil here. I'm going to take pictures of it next to a ruler so you can see the height and the length. I'm going to go ahead and give you the mass. And from the mass and knowing you can calculate the value from the density, you'll be able to determine the thickness of the piece of aluminum foil. So that's all the part of the demo that I need to show you here, and then I will move on over to the PowerPoint. So that was the video of me doing and performing the thickness of aluminum foil lab. So here is the data for you to be filling in on the bottom of your page. So under the data table, mass of aluminum pellets is going to be 29.6 grams. For letter B and C, I'm going to ask you to pause the video and read and record the volume of water in the graduated cylinder. So this is the 20 line, this is the 30 line, and you've got individual markings. Don't forget your sig figs. And here is the volume of water and aluminum pellets in the graduated cylinder. So those are recorded in B and C here. So pause the video, read them, be careful with sig figs. The next part is the length of aluminum foil, which is letter D. Here, you can see the whole piece of aluminum foil. I do have it right up to the edge, and here is a zoomed in picture of the actual ruler on the centimeter side. Pause it, record your length, remember sig figs. Here is the width of aluminum foil. Again, pause the video, record your data, don't forget your sig figs. Number the lines if you need to do that to help you out. And finally, letter F, the mass of aluminum foil is 3.1 grams. So the calculations, don't forget your sig figs as you're doing your calculations. So your starting sig figs are just as important as they always have been, and you need to be sure that you're using those as you go through the calculation. So for the first one, the volume of the aluminum pellets equals the volume of the aluminum and water that you read off the graduated cylinder minus the volume of water. Pause this as you need to. The density of aluminum equals the mass divided by the volume. The mass was the 29.6 grams. The volume is what you determined here. Watch your sig figs, watch your units. Volume of aluminum foil. Rearrange the density equation from here to solve for volume. Then use the mass of the foil, which was 3.1 grams, and the density of aluminum that you calculated back here, number 2, to determine the volume of the foil. Again, pause this as you need to with each step. Number 4, since the volume equals length times width times height, and you know the volume because you just found it here in number 3, and you measure the length and the width from the pictures, you can now calculate H. So you're going to want to do that. So again, pause it, do those calculations. So percent error calculations. We have not talked about these yet this year, and this is a good time to do it. Your book doesn't actually introduce this until much later, but you guys can handle this. So the percent error formula equals the absolute value, that's what these bars mean, between the difference between the accepted value and the experimental value, closing the absolute value, divide that whole thing by the accepted value, and multiplying it by 100 to get it in percent. So note that you cannot end up with a negative number because absolute value means that once you've taken this difference, whatever the number is, it's going to be positive. You have to force it to be positive. And your final answer ends up being percent. So for number 5, it says the accepted value is 2.70 grams per mil. So you're going to take the accepted value is 2.70 grams per mil, subtract the number that you calculated from back in number 2 for the density of aluminum. You're going to take the absolute value of those differences, and then you're going to divide that whole thing by 2.70. Remember sig figs. Once you've done that, multiply it by 100. You should end up with a number, and you're going to put that down as a percentage. Number 6 is very similar, only now you're looking at the percent error for the thickness of aluminum. The accepted value is 1.8 times 10 to the minus 3rd centimeters, and the experimental value is what you calculated back in number 4, which hopefully is very similar to this number. So accepted value is 1.8 times 10 to the minus 3rd. Experimental value is your number. Take the difference between those, the absolute value, so it's positive. Divide by 1.8 times 10 to the minus 3rd centimeters. Multiply that whole thing times 100. You're going to end up with a number, and the units on it are percent. So pause the video so that you can take your time in working your way through all of that. So because we're not at school, I thought that I could go ahead and work through one other lab today that we would normally do. And this is observations of a chemical reaction lab. And I'm going to walk you through the lab and have you record observations. I've taken pictures also. And this is a lab that had to wait until you knew the difference between a physical change and a chemical change, and knew those clues of what a chemical change, those 5 clues to indicate when you have a chemical change. So Acomet labs always record data in pencil. And I am going to stop this part and insert the video here. Hi ladies, here is the lab activity observations of a chemical reaction that we would have done in class if we had been there. However, I needed to wait until you knew the difference between a physical and chemical change. We'd already talked previously, I think back in chapter 1, about qualitative and quantitative. So if you read the background information on this lab, you recognize that it also introduces the difference between an observation and an interpretation. And just to try to be sure that you're kind of clear about that, observation is truly a fact, a statement of what you observe, what you see, what you hear, what you can smell. We're not tasting, and we're really not going to be touching any of this stuff in the lab. But an interpretation is based on the observations that you make, what you think about a substance. So I have a beaker here with some clear liquid in it. And if I asked you what it is, many of you would probably tell me water. And I would tell you that's an interpretation, because there's really no way for you to know if I might have isopropyl alcohol in there, water, another clear liquid. So an interpretation is taking the facts that you see and interpreting that and coming up with some type of conclusion. So in this case, an observation would be, this is a clear liquid. And you might believe it's water, you might believe it's alcohol, you might actually sniff using the waft technique and say, well, it doesn't have an odor, so I'm thinking it's not isopropyl alcohol or hydrogen peroxide, and I'm believing that it might be water, but I really don't have any way of proving that. So as you're going through this lab and filling out the data sheet as I go through it, try to be careful about making the difference between observations and interpretations. Sometimes we make those interpretations without even realizing it, but try to do your best at that as you go through this. So you can follow along with me in your lab handout. So hopefully you have this either printed out or accessible via the PDF file that was posted. And up here, right after the background information, are some goals. Those are the goals for the lab, and I'll talk more about what we're going to do with the goals in our write-up. But the 3 goals for this lab are to identify a physical and chemical change in the experiment, distinguish between observations and interpretations, and classify observations as qualitative or quantitative. So I've put together the materials here so you can see them. I have goggles. I did not bring an apron home. A glass stirring rod, a beaker, a metal scoop, a thermometer, calcium 2 chloride, and a piece of aluminum foil. The other thing it doesn't say that you need on here is water, so this beaker really was water, but you really can't tell that by just looking at it. So I am going to put my goggles on. And yes, I am truly wearing my goggles. So the safety, copper 2 chloride will irritate eyes and skin. If you come into contact with it, wash it off immediately. So if I do get some on my hands, I will go right on over to my kitchen sink and wash it off. And the other is, while observing the reaction, do not look directly into the beaker. observe the reaction from the side, which based on the fact that I'm videoing this for you, you won't have an opportunity to look in from the top. You will only look in from the side. So as you perform the experiment, record your observations in the data table on the next page. So you're going to be recording your information, your observations here as we go along. So using the Scoopula provided, measure out 1 scoop of the copper 2 chloride dihydrate into the beaker and record your observations. So that's the copper 2 chloride. So I will snap a picture of this so you can kind of see what the crystals look like. Take one from the top. So I will be posting these pictures. So here is where you're going to record down. Right now all we've got is the copper 2 chloride in the beaker. What do you observe? You can observe its color. You can observe what kind of size the crystals are. You can make comments about if it's shiny or not. Let me see if I can, I don't think I can angle it such that you can see it any better. So take a moment and record some observations. The next step is to fill the beaker about 1/4 full with water. So I'm going to put a little bit of water in here. And it says without stirring. Record your observation of both the crystals and the water. So now you can write down what you're observing before I even stir it. Then use the glass stirring rod to stir the mixture until the crystals are completely dissolved. Okay, now your observations. So you should have filled in here, here, and you're filling in this right now. And here's our household phone ringing. Try to minimize distractions, but you can't do everything. All right. So here it asks you to place the thermometer in the copper 2 chloride solution and record the initial temperature. Do not use the thermometer as a stirring rod, which we talked about previously. So I am going to put the thermometer in, and my daughter is helping me out with getting the initial temperature. Go ahead. Can they zoom in well? Is it light enough? Yeah, it's good. Okay. So I will post that so you can record that. And you're going to be putting that temperature here. Okay. Then the instructions say place a loosely crumbled ball of aluminum in the solution and record your observations. Stir the mixture occasionally, observe for at least 10 minutes, record the maximum temperature reached. So, I will set up a timer and put the aluminum foil in. So hopefully you can already observe some things about the reaction here and what's going on. So record some observations. I'm going to try to shine some light a little bit differently for you to be able to see a little bit better. Let's see here, can I angle this down? Not extremely well. So I'm going to take a picture. But you should definitely be able to see some things going on. And I'm hoping you're noticing that there are some signs that there is a chemical reaction taking place here. Some of those clues that I've asked you to memorize. And I am going to check the temperature out here. Oh yeah, it's increasing. Hey Becca, can you come and get a temperature for us? All right. And that was about a minute and a half into the time here. So if we were in the lab at school, I would have you observe this for 10 minutes. But instead of having you just sit here and observe this for 10 minutes, I am going to pause the video and come back when it's a little bit closer to the end of the time. Well, it was a little clunky, but not horrible. Can you come back to take another temperature? Thanks, Becca. It's kind of a nice experiment. It's the first one that they typically do in the lab. It's a nice reaction. Did you see the color that the thing starts out? The nice light blue. Okay. There's only 20 seconds left. I'm going to go ahead. I hope you liked that chemical reaction lab. I always think that everybody really likes the color that the crystals as well as the solution ends up being. So walking you through the lab. So here's a zoomed in picture of the crystals so you can record what that looks like on your lab data sheet. Pause as you need to. So the next thing, this is the initial temperature before the aluminum is added. I've got the picture so you can see this copper 2 chloride solution, and there's a zoomed in picture of the thermometer. Don't forget your sig figs. The next thing, this is a picture just so you could see what the aluminum foil looked like. It's shortly after the aluminum foil was placed in the copper 2 chloride solution. You can kind of see the solution. You can kind of see what's going on there. You can see some things here. You can see the color of the aluminum foil. So if you need assistance or need to add anything to your observations, do that now. Here is after the foil has been in the copper 2 chloride solution for 10 minutes. You can kind of take a look at the liquid. You can see the foil. You can now see it from the top. Add to your observations as necessary. And here is the final temperature at the end of 10 minutes. So zoomed in photo here of the thermometer so you can read off the temperature here. Don't forget sig figs again. And when I went to clean up, I drained all the liquid off and down in the sink like the instructions said. And the aluminum foil, or the remaining parts of the foil, is what I was supposed to throw out in the trash. And I thought I'd take a picture of it so you could see what it looked like. So what I'm going to recommend right now is that you pause the video and you work on filling out all of the post-lab questions. There are 5 questions here. It has a short table. It has some questions that it says to answer in complete sentences. So take your time, work on that, fill all that out, and then restart the video. Okay, so working on lab reports. We haven't done any real labs this year, so we haven't really written any lab reports. I think this lends itself very well to working on while you're at home. So what I'd like to do is go over the information that is in here for working on your lab report. So this is actually in the pink packet, pages 25 to 26 in the pink packet. And if you don't have the pink packet, I have posted these pages, or actually I will be posting these pages up on P-Learning for you to do. So granted, some of these things are a little bit, deadlines are going to be a little bit different, but let's walk kind of through this. So shown here is the format in which I'm going to expect you to put your lab report in. Each lab report must be typed. If there's any modifications to the particular formula for that specific lab, I'll let you know it before you start having a chance to type it up. Be sure to label each section and write everything in complete sentences, and all parts of the lab should be written in your own words. So this is what a sample lab report is going to look like. You're going to have your name, you're going to have the date, and you can put your block number here. So the lab is going to be, the title is going to be up here in bold, and then you're going to have 4 sections: purpose, procedure, results, errors. Have them called out and separated. They've bolded it and underlined, which is really helpful when I'm going through and reading it. How you do that, it doesn't matter. This format is fine. If you just bold them, that's fine. But I'd like to be able to clearly see the difference between the purpose, the procedure, the results, and the errors. So the title should be copied directly from the handout. So this is the one thing that is not in your own words. So you're going to take the title from the lab. The purpose here is actually you're going to restate the goals of the experiment in your own words. So if you look back at the observations of a chemical reaction lab, there are 3 goals listed there. The first one is identify a physical and chemical change in the experiment. So in your purpose, you should reference that purpose of this experiment was to be able to identify a physical and chemical change in the experiment. You're also going to put the other 2 goals there. So you want to explain what we were trying to demonstrate. Were we making observations, or we were trying to calculate something? So there should be 1 to 2 sentences in this section, and most of the time you have multiple goals in an experiment, so it should be very easy to get a couple sentences. In the procedure, you're going to write in your own words what was done. This is going to be a little bit more challenging for you because you actually didn't get the opportunity to do it. Hopefully, by looking back on the video and reading through the procedures, you will still be able to do this. So be careful. Do not write a step-by-step procedure. I don't need you to recopy the procedure that was on the original lab handout. And don't go into a whole lot of detail. So this should be an explanation like you would give your parents to explain what did you do in the lab. If they asked you, what did you do in the lab, or what did Dr. Kari do in this lab, you're going to be able to explain it just in words. And there should be a few sentences. Results. Results are what were the important things you were determining in the experiment. So this should reflect back to what you wrote in your purpose. For the observation of a chemical reaction, you had 3 goals. You want to identify that you met all 3 of those goals in that particular lab. So things should be, we demonstrated, we observed, we classified, we distinguished, and you're going to include the results from the relevant sections of your data or any calculations or questions that refer to those specific results. Do not recopy your data table. Do not recopy the post-lab questions or the calculations. I don't need to see those again. They're already on your handout, which you're going to turn in. So just reference your purpose, those 3 goals, and show that we met those. Errors. Percent lab error should include a calculation. If you had a percent error calculation, you notice in the 2 labs that we just worked through, the thickness of aluminum foil, you had 2% error calculations. The other one, there was nothing to calculate, so there was no percent error. So you should include a percent error if there is one, but also you should indicate where we might have had an error. Where could we have had a mistake? So things are going to be like maybe errors from inaccurate measurements. Maybe Dr. Kari typed the numbers around wrong on your PowerPoint, so everything is going to be off. So you should always have a couple of sentences for this. So again, this seems to be really challenging for a lot of students. So just to reiterate, the purpose should reflect the goals that were stated on the lab handout. Procedures should be on your own words that you explain what was done. Please do not copy the steps on your lab handout. Results, do not copy the lab data table, do not copy calculations, questions. Go back to the goals and explain how the lab achieved or maybe didn't achieve the goals. Include final results from calculations. Percent errors. Explain what could have gone wrong, why there could have been errors, mistakes, limitations to getting the best answer possible. Not all labs will have a calculation for this section, but all labs will need a discussion of potential errors. Here is the rubric that I will be grading your lab reports on, so you can clearly see what this is. This will also be on P-Learning, but it is page 27 in your pink packet. So wrapping up for today, please submit the following on PowerSchool for your classwork grade by tomorrow morning at 8. So review questions for today that were assigned for your block. Photos of data and questions for both labs. So just go ahead and put all of that into one document. Make the photo of each page take up the entire or the majority of the page so I can see it. I've had a few people who put like 6 photos on a page and I can't see that, and sometimes they're sideways. So if you can make them take up the entire page so I can really see it easily, that will be helpful. Also, the survey is here. The link is also on P-Learning. So that is your classwork. Homework due Tuesday at 8 a.m. So you've got a couple more problems to do from chapter 3. Not a lot, not really hard. I am going to ask you to submit your lab report for thickness of aluminum foil lab. If you are able to submit that before Tuesday morning, I will start taking a look at them as I realize that they're submitted. So I'm going to suggest waiting to do the other lab report until I've had a chance to look at these to ensure that you're following the instructions, the rubric is good, that you're not having any issues. So if you submit your thickness of aluminum foil lab prior to that Tuesday morning, send me a quick email and just let me know you put it in there and I can look at it anytime. And I will work on making comments as quickly as I can. So in addition, for Tuesday, I'm going to ask you to gather these items because we're going to work on a chromatography lesson during our class time. You're going to want some watercolor markers, and they need to be things that are combination of colors. So not the individual primary colors, but you want things that are like purple, green, orange, or black. The other thing that works well is food coloring. Again, it has to be a combination of primary colors. The paper that we would normally use at school would be filter paper. However, you're not going to have access to that. Things that are working really well seem to be coffee filters or a paper towel. If I find anything else that works really well, I'll let you know. But as of right now, computer paper doesn't work. Paper plates don't work. Notebook paper doesn't work. They don't actually allow the water to go into the paper well enough. So don't feel that you have to go out and buy coffee filters. Please do not feel that you need to do that. Paper towels are just fine. The other thing you're going to need is a tall glass, preferably one you can see through, but it doesn't have to be clear all the way through. The one that I'm using actually has some decorations on it, but I can see through it well enough. You're going to need a pencil, a paper clip, or a small piece of tape, and some water. So you're going to want to gather those items before you start watching Tuesday's video, where we're going to actually do some chromatography. I am going to do one demonstration of chromatography, and then we're going to work through doing another one, and we're going to see how your home lab works. So chapter 3 test. This will be due on Thursday, April 20th. Man, that's really off. So it is actually April 2nd. I don't know where I got April 20th. Okay, it's going to be in 3 parts. So you're going to be required to do 2 one-pagers, one on physical changes and chemical changes. The other will be on pure substances, elements, and compounds versus mixtures, heterogeneous and homogeneous. You can select whatever format you want to use. I will upload a bunch of PDFs with the one-pagers in them, and you can select whatever format you want to use. If you are unable to print, you can draw these on paper. I do expect that you're going to use a ruler and that you'll have solid, thick black lines to differentiate between the different parts of the paper so it looks neat, tidy, and organized, just as if you were using any of the pages that I handed out in class. So that's the first part. The second part is I'm going to ask you to take photos from around your house or your neighborhood. Please don't use photos from the internet. I would really rather see what you've got around your own house. So you're going to take 5 photos that show a physical change and 2 photos that show a chemical change. For each photo, you're going to write a brief explanation of 3 sentences that explain why these are physical changes or why they're chemical changes. And you're going to be sure to include the clue of the 5 clues that is observed for your chemical changes. This will all need to be in one document, and it will be due on Thursday. The last thing is going to be a short online quiz that's going to be available to take on Thursday, demonstrating some knowledge of the material. I'm still working on determining my favorite way for doing this, so there will be more details before Thursday. If you have found with another teacher that a certain test or a certain way of doing this online has worked really well, please let me know. And I will look into whatever I can over the weekend to determine the best way of doing this. So looking ahead, there are 2 students who need to take the test. I'm preparing some videos and things for you to watch to review those topics. And so next week there's going to be some Actually, it's not going to be much next week, but Chapter 2 math review, and we'll be heading into Chapter 4. So, ladies, it's been great having a chance to talk to you. I really wish I could see you. Definitely missing everybody. Hoping that we get an opportunity to get back together soon, and I will be in touch. Have a great weekend, ladies.
Dr. Christ's husband said y'all are awesome. Keep doing it.
So I don't know if you heard that. That was my husband. He's like, y'all are awesome. He's been hearing back some of the feedback that I've been seeing on surveys and things, and you guys are doing great. So please fill out the survey. There's a couple questions in there that I really want to see your answers to. And ladies, keep hanging in there. If there's anything I can do, don't hesitate to reach out and send me an email. And have a fantastic weekend.